All right. We're actually going to do 2 pages in the note packet today, just because I wanted you guys to have graphs of what we call the parent function, or the most basic version of a square root function, and then also a cube root. So we're going to do this on the front here of the next page, and it should say before 6, 7 notes, radical parent functions on the top. And we're just going to, on the front, do the square root, and then we'll do the cube root on the back. Sorry, guys. Let me see if I can kind of blow that up so you can kind of see the whole thing. Okay, so I just made a table, and then hopefully you all are familiar. Each of these are just perfect squares. So I'm just going to pause the video real quick and fill in the table, but I'm literally just going to plug each of these in for x and take the square root of each number. All right, so all those are perfect squares. I just filled them in real quick. And then I'm going to go ahead and plot these points on the graph. Just kind of estimate a little bit. The y-axis goes by 2's, and then the x-axis also goes by 2's. So just do your best. I was trying to fit it all kind of on the screen so you could see it. So then as you go through, just kind of estimate if you have any odd x values or odd y values, just kind of estimate in between the 2 grid lines for an odd number. And I'm going to pause it again. All right, so I got my points on there. And again, I just kind of estimated right in the middle for the odd points. And I know this is kind of hard to see the way this is spread out, but the basic shape goes like this. And what we're doing, we're just kind of have a curve. And I know that looks really rough on my paper, but that's the general shape of that if you have a positive square root that starts at 0, 0. Now I'm going to go down and do the same for the negative, which when I do this, the only thing it's going to do, it's just going to multiply each of the terms after I plug them in and take the square root, just going to multiply them by -1. So actually, let me just go down and do it right away. So we'd have 0. This would be -1, -2, -3. They're just all the same numbers in the table above. They're just being multiplied by -1. So if you got a negative in front of a square root, the general shape it's going to take is going to be kind of like, it's like the bottom half of a sideways U. If you put them all together, we're going to see this in the notes today, but if I do this, plus or minus the square root of x, it's a sideways parabola is what it is. When they restrict and do just a negative, or on the one we just looked at, just do the positive half, that allows it to be a function. If it's not passing the vertical line test, if I would graph the whole thing together, it would not be a function because there's a bunch of different places where I could draw vertical lines and touch more than one point. So usually with your square root, when they call it a function, they're going to restrict it to either the positive, which would be the top half, or negative, which would be the bottom half. So if you go through and graph this, so I'm going to do 1, -1, and then 4, -2, and then I've got 9 right in the middle, -3 right in the middle. I'm going to go over to 16, 4, that'll be on a nice point. Sorry, -4. 25, -5, I'm just kind of estimating middle of each of those grid lines. 36, -6. And then I've got 49, -7 all the way here. And so again, it's kind of drawn out here. And it's like a bottom half of a sideways parabola that looks a little rough, but at least you guys have the general idea. Those are square roots. Okay, now on the back, we're going to do cube roots. So you can take the cube root of a negative number, and I do have 2 different versions of these. This is just a basic parent function, just cube root of x, just to show you what this looks like. So if I take the cube root of -64, I get -4. Cube root of a negative is going to be a negative. So I'm just -4, -3, -2, -1, 0, and then cube root of a positive is a positive. So 1, 2, 3, 4, just so you guys can see the general shape here. Okay, so because I can, we're going to have to estimate here on this. All right, so this goes by 5s. So I'm going to graph the point, let's see, 1, 1, kind of maybe here. 8, 2 is going to be maybe in there. 27 and 3 would be like this. And 64, 4, something like this. Now, this kind of takes the same shape, that kind of like sideways U shape, The difference here, because I can take the cube root of a negative number, instead of following up with the bottom half of the sideways u like we do for a square root, it actually flips it backwards because you can take the cube root of a negative number. So 1, -1, maybe like right in there. And then we're going to do 8, -2. Again, these are just kind of estimated because of the way the scale is here, but we're just trying to get a general shape so you guys can see it. -27, -3, maybe like right in there, and then -64, -4. So instead of going forward and making a sideways U, it flips back. So just like the general shape, it's got a point in the middle, and then one side goes forward, one side goes back, because you can take the square root, or sorry, the cube root of a positive number and then cube root of a negative number. Now, in this situation, what's going to happen if you have a negative in front of the cube root, it's literally going to take and flip the graph over the y-axis. Okay, so basically, here, if I take a cube root of -64, I'd get -4, but then I have a -1 in front. So that's actually going to make each of these positive. And then if I take the cube root of 1, and then I have a negative out in front, that'll actually just make each one of these negative. If you plug in that value for x that I've got in the table there. What that's going to do, it's going to flip this to go backwards. So I'm just going to, above the top, kind of give you a general shape. Basically, if you got a negative in front of your cube root, the first side is going to go up and left, and the second side is going to go down to the right, which is reversed from what we just graphed. And so I'm just going to pause this and put it on the graph real quick. Sorry guys, my graph got a little rough because I was confusing it with the square roots that we were just doing on the front. So it should look something like this in general. And this is what we're going to actually sketch today. Okay, so this is actually what we're doing today, is to graph these and shift them around. So just in general, just to show you this, this is just a regular y equals x squared. That's a parent function for a quadratic. Square root is actually the inverse of that. So it's just flipping that over the line y equals x. And then again, like I mentioned to you guys here, just so it becomes a function, because this is not a function. It fails the vertical line test in a million different places. So they restrict either doing the positive, which is the top half of the sideways U shape, or the negative, bottom half of the sideways U shape. And that way we have a function. These would both pass the vertical line test. So if you just see a square root of x, it's just the top half of that sideways parabola. If you see a negative, it's the bottom half of that sideways parabola. Now we're going to translate these today. So in general, vertical translation is going to move the graph either up or down, and the way that's going to appear in an equation would be something like this, where you're going to have something added or subtracted. I don't know why I just wrote an absolute value, forgive me. Square root of x plus k works the same as an absolute value. So this is going to move up or down exactly the way that you think. And then a horizontal translation is going to move the graph left or right. That translation is actually going to be inside the radical, and it would look like that, x minus h. Now, inside, this is going to go the opposite way you think. If it looks like a -5, it actually is going to go 5 to the right. Or if it looked like a +5, it would actually go 5 to the left. If it's outside, that's moving it up and down. That goes exactly the way you think. If this is +4, we're going up 4. If it's -4, we're going down 4. And then a diagonal translation just means you're going to shift either up or down, and you're going to shift left or right within the same equation. So what that would look like, x minus h plus k. hk is going to be where you start. All right, so here's what we're going to do. We're just going to work on each one of these equations, and some of them are written as y equals, some of them are written in function notation f of x, but it's the same thing. Okay. Inside with the x, nothing in there, so we're not going to shift left or right. Outside we have a +3, so this would shift the graph up 3. This is a positive square root of x, so just looking for the general shape and then the starting point. The you would have correct, and then we'll talk about domain and range here in a second. So I would just go 0, 3 here, and just the top half of that sideways U shape, and you're just going to do a sketch. It does not have to be perfect. That's all I'm looking for. This one, we've got nothing inside with the X, so we're not going to shift left or right. And then we've got a -2, so I'm just going to copy that down. And this, again, this is a positive square root of X, so 0, -2. This should be the top half of that sideways U shape. And then I've got one more. Now, I do have something inside with the X here, so this is the opposite of what it looks like. There is nothing added or subtracted, so we're not going to shift up or down here. So opposite, nothing out there to copy. So again, this is a positive square root, so I'm going to start this at -4, and then we're just going to do a little, the sketch of that general shape of that sideways U. Now, each one of these, for your domain, you want to come from left to right. We're just going to write some interval notation. So the first point I touch is going to be where I started the graph, and you just want to copy the X coordinate, which is 0. And I'm going to put a bracket there because I actually touched that point. And then this goes to the right forever, so that's going to go to infinity. If I look at this graph, again, and this gets tricky for people, but the first X value you touch is going to be this point, and the X value there is actually 0 again. And we're going to go to infinity because we're going to the right forever. And then the last one here, the first point you're going to touch is this one right here, and the X value of that point's -4. Use a bracket, and then it goes to the right forever. All right, now for your range. When you do your range, you want to approach from the bottom to the top when you write your interval. So if I'm approaching this graph from the bottom, the first point I touch again is going to be where we started, but this time I want my Y coordinate, which is going to be 3. And this does go gradually, but it does go up forever, so that's going to go up to infinity. If I do this one, approach from the bottom, first point you touch is right there. The Y coordinate of that point is what you want for the range, which is -2. And then we're going up forever. And then the last one, again, make sure it's the Y value for the range, X value for the domain. First point you touch is going to be where we started. The Y coordinate of that point, though, is 0. And then it's going up forever. All right, we're going to scooch these guys up. Okay, got a couple more graphs. Now, these two are both going to be what we call a diagonal translation because we're going to make two moves. We're going to go either left or right, and we're going to go up or down. Get that starting point, you're just going to do opposite copy. So this is going to be 4, -1. So I'm going to go 4 to the right, down 1. And again, we're just doing a general shape. This is a positive square root of X, so this should be the top half of that sideways U shape. And let me just do domain and range while we're here. Okay, from the right, first point I'm going to touch is this point where we started. The X value for that point is 4, and then we're going left forever, or right forever, sorry. And then here, if I come from the bottom, again, that's the first point I touch. And the Y coordinate there is -1, and that's going up forever. All right, this guy here, I've got radical square root of X plus 2 minus 5. So opposite copy is going to be my starting point. So I'm going to go left 2 and down 5. This is a positive square root of X. There's no negative in front of it, so it's the top half of that, sideways U. And again, come from the right. First point you're going to touch is this one. And your X value there is -2, and it's going to the right forever, so it goes to infinity. For the range, again, the first point you're going to touch is where we started. This Y value is going to be -5. And then, again, it's going up forever very gradually, but it goes up to infinity. All right, now, these last two, I want to pay attention to this. These have a negative out in front of them. So when I graph this, this is just going to be that instead of the top half of the sideways U, this is going to be the bottom half of the sideways U. So the sketch is going to look something like that. Same rules still apply, opposite copy. This is going to be -3, 1. So I'm going to go left 3 and up 1. What I'm going to do differently here, though, since it had that negative out in front, we're going to draw the bottom half of that sideways U. Again, it's just a sketch. Now, domain should be exactly the same look and process that we've done for all these other ones, right? So if I come from the left, that's the first point I touch. X coordinate is -3. It is still going to the right forever. It's just going down this way instead of up. The range is different here. This goes very gradually, but that arrow does point down forever. So I actually want to start my interval with a parenthesis and a negative infinity. And if I was tracing this graph, I would stop touching it at this point we started the graph at. So that would be the last point. There would be nothing above that. So you want to start your interval if it's pointed down with negative infinity, and we're going to stop at the y coordinate of that point. All right, and then we've got one more opposite copy. This is going to be +2, +1. So I'm going to go right 2, up 1. And again, that negative in front causes me to do the bottom half of that sideways U just to make sure it's a function would pass the vertical line test. And your domain here, we're coming from the left to right. First point you touch is going to be an x coordinate of 2, going to the right forever. And then for the range, if I come from the bottom, this goes very gradually, so it's hard to see, but that would point down forever. So I would be always touching part of the graph, and I would stop touching the graph at that point right there. So you want to start your interval here with negative infinity, and you are going to stop at the y value of 1. Okay, now on the back we're going to do cube root functions. So just to show you this is just y equals x cubed. And the cube root is the inverse of that function. So this is a reflection of this graph over the line y equals x. And we did this just a couple seconds ago with our parent function. So this graph is if you have a positive cube root of x. And if you put a negative in front of a cube root of x, it flips it over the y-axis is what it does. Both of these are functions. Both of these were passing the vertical line test, so we don't have to do anything to restrict that for a cube root because you can take the cube root of both a positive and a negative number. Okay, now, if you notice on the back, I just have some graphs. I don't have domain and range for each of the graphs below because they are actually all the same. So I just wanted to look at that with you here. So left and right, this goes right forever, left forever. Same thing here, it just flips it over, but it's still this side goes left forever, this side goes right forever. So you cover the whole x-axis. So all real numbers are negative infinity to infinity if you want to do the interval notation, but any cube root function is going to touch every single x, every single y. And it's exactly the same for the range. I know this looks really gradual. This would eventually, it would go up forever. This would go down forever. This graph does as well, it's just flipped over. Here, this side goes up forever, this side goes down forever. So it actually has the same domain and range that you're going to cover all the real numbers anytime you do a cube root function. Not true for square root, but is true for a cube root. So all these cube roots that you're going to see have the same domain and range. All right, now, when you do a vertical translation here, vertical again means we're going up or down. This would look like y equals cube root of x, and I'm going to put plus k. This is going to be like what we did on the other side. This is going to move exactly the way you think. And this time your h and k is going to give you the middle of that cube root graph. For horizontal, that's left or right. And this would look like x minus h under the radical with the x. So with the x moves the x coordinate of the point, outside moves the y coordinate of the point where you're going to see it in the middle. And the diagonal is going to put those two together. So either left or right and up or down. And hk is not a vertex here, it's the middle of the cube root function when you do it. All right, so how does this work? All these have domain and range negative infinity to infinity. So what I'm looking for here is a sketch. There's nothing inside with the x, so we're not going left or right. And I have a +2, so we're going to scooch up 2 from those parent functions you see graphed above. So here's what I'm going to do. Here's 0, 2. This is a positive cube root. So we're just sketching this. You should have kind of like a sideways U that goes forward top half, and then part that flips backward, the bottom half, that would be the general shape of a cube root function. The reason is I can take the cube root of both positive and negative numbers, so that's why we're going to flip both directions. That middle point is based on what we were doing with our opposite copy. So same thing here. This is x minus 4, so it's going to be positive 4, copy the 3. So we're going to go 4 to the right and up 3. All right, now all I'm doing here, this is a positive cube root, so it should go up and to the right and kind of flip back and go to the left. Just as we're just doing a sketch. I'm looking for that middle point and then do the two curves go the correct direction. This one, opposite copy, this would be 3, negative 2. So for this one, again, this is a positive cube root, so we're going to go up and right and swoop back and left. Now, I think, yep, all three at the bottom here, these all have a negative in front. So that is going to just flip our graph over. So we're going to still do our opposite copy here. This would be positive 1, and then there's nothing added or subtracted to the side. So this is going to be 1, 0. So I'm going to go over 1, up 0. So right here. Now, this case, if I plug in a positive value bigger than 1 to try to take the cube root there, it's then going to get multiplied by a negative. So this is going to flip this to go backwards. So this is going to go this way. And then this way is going to go forward. So this, if it's got a negative in front, you're going to flip back to the left, or up and to the left backwards, and then you're going to go down to the right forwards to kind of give me the sketch. Negative cube root, this is negative 2, negative 3. So we're going to go left 2, down 3 to get that middle point. Again, here we're going to swoop kind of backwards to the left, and then forwards down and to the right to get that general shape. It doesn't, I'm not plotting any specific point except that middle point. I just want you guys to be able to know what this generally looks like. And then I got one more here, opposite copy. So this is going to go left 3, up 1, 2, 3, 4. And then I'm just paying attention, this is negative. So negative cube root is going to go up and back to the left, and then go down forward to the right to get my sketch.